Okay, let's start inverse functions. We need to know something about composite functions in some parts of inverse functions, but let's start directly inverse and then I will explain the composite before we continue the inverse functions. For example, we have set A equals 0, 1, 2 and set B equals 0, 2, 4. So we have a relation given between set A and set B. This is set A, and this is set B. And suppose we have a relation from A to B called F. F is a relation from A to B. A has three elements in it, 0, 1, 2. B has three elements as well in its domain. F is a function. F is a function from A to B where x goes to y, x belongs to A and y belongs to B, where y is f of x equal to x. So 0, if we substitute in the relation y equal to x, instead of x 0, then y will be 0. 0 goes to 0. 1 goes to 2. And we substitute instead of x 1, 2 times 1 is 2, and 2 goes to 4. Now, this is a mapping, and it's one-to-one mapping, right? And it should be like that. We will discuss this later. But now, do we have F inverse? Yes, F inverse will be from B to A. F inverse will be from B to A. And the relation, instead of double x, will be half x. This is the inverse. How we found that, I will discuss now. So, because 0 will relate back to 0. If 0 is double 0, then 0 is half 0, right? And 1 is double 2, 2 is double 1, then 1 is half 2. 4 is double 2, then 4 is half 2. How did we find this inverse? We will discuss that later on in detail, but now we just take y equal to x. It's very simple. Two steps we have to do. First, we interchange. What's the meaning we interchange? We, instead of y, we change x, and instead of x, we change y. Inverse function, the domain will be the range, and the range will be the domain as we saw here. The domain of the function f, this is the range of function f. In the inverse, the domain will be the range, and the range will be the domain, because we start back from range to domain. So the range will be the domain of the inverse, and the domain will be the range of the inverse. This means we substitute instead of y, x, and instead of x, y. We say we interchange this. Interchange means go to the original relation and interchange. Instead of y, we put x, and instead of x, we put y. Then we do what? Then we go to solve for y. Find y. If 2y equal x, then we divide both sides by 2. We get y equal x over 2. And this will be, if y equal to x is the function f of x, this one will be the inverse of f of x. We can find x the same. We can find x in terms of y, then we interchange, or we interchange and then we find y in terms of x. Both are the same. Let's see. Property. We do have a property here. If f is a function, let's see when we have inverse. First, f is a function. It should be continuous and strictly monotonic over an interval. What's the meaning of strictly monotonic? It could be strictly increasing or strictly decreasing. It should be monotone. So strictly monotonic, either increasing or decreasing. Then f admits an inverse function, f inverse, over either f of a, f of b, if it's strictly increasing, or f of b, f of a, if it's strictly decreasing. So the function should be for sure defined, first over an interval. It should be continuous over this interval and strictly monotonic. This means it should be either increasing or decreasing function. The inverse will be defined what's the meaning of f of what's the meaning of interval AB? Interval AB goes in relation f to domain f of A, f of B. Now, this is the function, right? Now, what is the inverse function? Inverse function will goes from f of A, f of B, because the range will be the domain, and the domain will be the range. Okay, this is true if the function is strictly increasing, and instead we put f of B, f of A if the function is strictly decreasing. Let's do some examples. First, f of x equal x squared. F of x equal x squared. we need to and it is given defined on 1 3, right? All right, first it's given defined. First we do what? This is number 1. Okay, this is number 1. We have f of x equal x squared, and it is defined on 1 3. First, what is the domain of x squared in general? It's a polynomial function, so the domain of f is all sub R. So we know that when it is polynomial function, the function will be defined on R and continuous. So it's continuous over R. Since it's continuous over R, then it is also continuous over the part of R which is only 1 3, because we need just this part over here. First, this is the first condition. It should be continuous. Second condition, we find the derivative. Why we find the derivative? What is the derivative of x squared? Derivative of x squared is 2x over 1 3. Just over this part, if we substitute instead of x 1 and instead of x 3, this is strictly positive function. Derivative is strictly positive. This means the function is strictly increasing function. This means those two gives us that f inverse exists. F inverse exists. Okay? Now let's find the domain. Let's find the domain and the range. First, it's defined on 1 3, right? We do what in this case? We find f of 1. F of 1 is 1 square, which is 1. F of 3 is 3 square, which is 9. What do we mean by that? This means the domain of f given as 1 3, its range goes to 1 9, because it's increasing. F of A, f of B. The inverse, the domain will be 1 9 and the range is 1 3. Now we go and find this the expression of f inverse. We know that y equal x squared. Let's not to interchange here now. Let's find x, right? Let's find x. To find x, we have to radical both sides. So x will be two cases to be considered, either plus or minus radical y. If we put radical to the first side and radical to the second side, x will gives me two cases to be considered. But where x is found, x belongs 1 3, and 1 3 all positive. So x gives me just a positive value. This means x should be equal to only plus radical y. Now we interchange. This means y equal radical x, and this expression is the expression of f inverse of x. Simply we just go for it like now, like that. And in the other videos you will see exactly what I'm talking about more and more, because we are going to more details. See you in part 2. This is inverse part 1, and we meet again in inverse functions part 2.